Assalamu alaikum. Welcome to another session of data structures and algorithms using C, C++. My name is Dr. Bilal Wajid, and today we're going to talk about double linked list and specifically the function create. Now, we have already discussed a linked list. This is how a linked list looks like, and we've been discussing it from lectures 23 to 27. Now we are discussing a double linked list. A double linked list has the additional advantage that every node can point to the node previous to it and a node next to it. And because of that, you can actually traverse in either up or down. In a linked list, you can only traverse down from the beginning to the end. This is what a circular linked list looks like. It's very similar to just making sure that the last pointer points to the first one, and if the first pointer points to the last one, you end up with a circular linked list. A circular linked list is more appropriate for periodic elements like a timetable, for instance. Now, for every single node, whether it's a double linked list or a circular linked list, it has the same definition. So you can use a structure where a given node can have multiple variables in there. But apart from having these multiple variables, it has to have a pointer as shown here. You can use the name previous, a pointer previous that can point to the previous node, and a pointer named next that can point to the node that comes after this particular node. Now, we've already discussed the basics. That's basically a definition of a structure node. This lecture is going to talk about create. Now, some basic fundamentals. You really need two global variables. One is called length, that holds within it the length of a double linked list. So as and when you start adding elements to the linked list, you just increment the length. And obviously, if you start deleting elements, you decrease the length by 1. You also need a start that gives you the location of the start, hence the name start, the beginning of the double linked list. Now, when you don't have a double linked list, or you could say the double linked list is empty, you can really show it by ensuring the length is equal to 0, or by ensuring that start points to null. Okay, and you can code this really simply by saying integer length has been assigned 0, and node pointer start, and start has been assigned null. Now, the first thing is your list is empty, so start is pointing to null. That tells you that right now the list is empty. So you shouldn't be adding a node, rather you should be creating the double linked list. So once you create a double linked list, start shouldn't be pointing to null anymore. Start should be pointing to a real node, right? And then you can just change the value based on what it points to, and say the value is now assigning to next. Now, because you're creating, and this is the first node, now previous has to and next both need to be initialized to null. In other words, start is pointing to this node, and behind this node there is nothing, and beyond this node there is nothing. Hence, truly, this is the definition, or this is what happens in the create function. Now, if you want to code start points to null, you can simply check if length is equal to null, or you can check if start is equal to null. In both cases, it literally means the same thing. But then if you want to create, you can just do it by ensuring start has been assigned as new node. When you do something like this, the operating system assigns a location in the memory equal to the size of the node. So if the node contains hundreds of variables, obviously the size in the memory location would be significantly larger than a node which has only 3 elements in there, the previous, value, and next. Now, once you've done that, you can access individual elements of this particular node by using the start. So when you say the value that starts point to has been assigned next, you would see that this value is being updated. And obviously now previous and next, you want to update them. You just simply say previous, that start points to has been assigned as null. So this has now been assigned to null. It's pointing to null. And starts next now has been assigned as null. It means next is also pointing to null. Okay, now this is the complete code of the function create. I've deliberately kept it as void because length and start are being, updated, and they are the global variables. Now interestingly, if the length is not equal to 0, then you shouldn't be really trying to create a double linked list because it's already there. You should rather be adding a new node to your already existing double linked list. Okay, again, I would strongly recommend you try these codes before moving on to the next lecture. In the next lecture, we will be talking about traversing a double linked list and similar functions. Subscribe and hit the bell icon to get notified for new videos. That's it for now. See you next time. Bye bye.